going to be sharing with you the solution to target number 6. So the problem reads, an integer b is chosen at random between 10 and 30 inclusive, and an integer c is chosen at random between -10 and 10 inclusive. What is the probability that exactly one of the roots of the polynomial x squared plus bx plus c is positive? Express your answer as a common fraction. So to get started, we want to be able to confirm that there are 2 real roots to this polynomial. So by looking at the determinant, which is b squared minus 4ac, we see that a in this equation is just 1. So this becomes b squared minus 4c. Now, if the determinant is positive, and only if it's positive, we know that there are 2 real roots to this polynomial. So we can confirm that it is always positive by seeing that the smallest possible value for b squared is when b is equal to 10. So the smallest possible value for b squared is 100. And for c, to maximize that, we say that c is equal to 10. So the maximum value for 4c is 40. And the difference between that is 60, which is positive. So we know that the determinant here is always going to be positive. So we know that there are 2 roots to this polynomial that are real. So from there, we can just do casework. By Vieta's formulas, we know that c is the product of the roots, and b is the negative sum of the roots. So negative b is the sum of the roots. And we know that we want exactly one of the roots of the polynomial to be positive. So they can't both be positive. Either one is positive and one is 0, or one is positive and one is negative. If one of the roots is 0, then c is going to be equal to 0 times some other number. So c is going to have to be equal 0. And since we know that this number is positive, that means negative b equals 0 plus x is going to be a positive value. And if negative b is positive, then that means b is negative. But we know that b is in between 10 and 30 inclusive. So b can't be negative. So this is a contradiction. So one of the roots can't be 0. So that means c cannot be 0. And c can't be positive, because if c were positive, then either both of the roots would have to be positive or both of the roots would have to be negative, which we're not looking for. So c must be negative. And we see that there are 21 possibilities for c, and 10 of those are negative when c is in between -10 and -1 inclusive. So probability is those 10 cases over 21, which is our solution.
This is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.